practice drawing isomers for an organic molecule. This question wants us to draw the isomers for C3H7I. So since we only have 3 carbons, we know that the 3 carbons are going to make up the backbone of the molecule. And now we can just fill in, making sure each carbon has a total of 4 bonds, and we can fill in the hydrogens, and we know that one will be replaced by the iodine. So what I've just drawn is our first isomer. And then how can we draw a second isomer? So we know that our current position for the iodine is at the end. So it's on one of the terminal carbons. So if we put it on an internal carbon, then that would definitely be a different isomer. So instead of putting the iodine on the end, we're going to put it in the middle. And then we'll just continue to fill in with the remaining hydrogens. And then this would be a different isomer, because instead of having the carbon on C1 or C3, we have it on C2. So are there any other options for isomers, or would they just end up being identical molecules? So in this case, these are our only 2 isomers, but let's figure out why. And this is very useful if you have a molecular modeling kit, because then you can easily rotate the molecules and make sure, is this an identical molecule or is it an isomer? A constitutional isomer, to be specific, meaning there's a different connectivity of atoms. So let's say instead of putting the iodine on the carbon that's on the right, let's put it to the carbon on the left. And then we'll continue our backbone and fill in the rest with hydrogens. So we still have the same formula, C3H7I, but instead of having the iodine on the right, we have it on the left. But what's going to happen here is if we flip the molecule, this is going to be identical. And then same with if we had the iodine on the hydrogen on top. If we'd flip these 2 molecules, it's still bonded to the same atom, and that bond, since it's a single bond, it can rotate. So that's the same connection of atoms, so it's identical, it's not an isomer. So showing one more example, here we have the iodine on top, but what if we put it on the bottom? Is it still the same molecule, or is it an isomer? So in this case, again, if we just rotate the molecule, in this case flipping it, and then we're going to flip it on that plane. So we're going to flip it, I'll use purple for this. If we flip it on this plane, then we'll get the same identical molecule with iodine in the same position. So marked as 1 and 2 in red, these are the only 2 isomers for C3H7I.